Hey, this is Christian. I'm back again to solve some more algorithm problems. Um, I don't know if you guys have ever felt like you really don't want to do something. I personally, I just tried to record another video, it crashed, and I kind of told myself I was going to record again tomorrow, but it's probably not going to happen. I work tomorrow, and I just know myself. So sometimes you gotta hustle through, and to be honest, most of the times that I do hustle through and beat my resistance to doing something are some of the best moments I have in my life. For example, if you want to go to the gym, and there have been times where I sit outside for 20 minutes because I just don't want to go, but I know I had made a plan to. So I just sit out there because I didn't want to. I knew if I left, I would regret it, and I just didn't have the willpower to go in. So I'll try to stop thinking about it for a minute, and then I'll just force myself to go. And you just don't even think about it. And honestly, after those workouts, I felt personally amazing. I was really glad I did go. I was a little bit tired, a little bit fatigued, but honestly, just working out is, I don't know, it's a good feeling. It's good for you too. Just try it. Alright, so let's get started on this problem. I did take some time to read this beforehand, so I can get started quickly. I'll give you a quick explanation. Divisible sum pairs. So as the title says, we're going to be testing each pair where I is less than j. So I is going to be the first number, and then we're going to compare every other number after it to it. We're going to be finding the sum, and we want it to be divisible by this number k. So we're going to be using modulus, obviously, and if it's divisible, it'll equal 0. If it's not, then it won't. So it looks like, what are we outputting? Okay, so we're outputting the number of pairs. So we don't even have to store these two values, these pairs. We just have to count the number of pairs there are. Okay? So divisible sum pairs. Okay. We'll rename this to count divisible sum pairs. We're trying to use more meaningful names, or use verbs for methods, nouns for integers, variables. Okay, so let's find it down here. Divisible sum pairs. I'll name it that instead. Okay, so we're receiving 3 arguments, n being, I'm guessing, the length of the array. I don't actually remember what n is. 2 to 100. That's number of space integers. Okay. I don't think we need it passing here, do we? I don't think so. The first line contains 2 space separated integers n and k. The second line contains n space separated integers. Okay, so we don't actually need n passed into this method because it's the length of the array. So it's kind of redundant. Okay, so k and ar. So I'll be able to change the ar to number set, and then k will be divisor. Is it dividend or divisor? I don't know, we'll call it divisor. That's what we're gonna go with. Alright, so let's do our classic setup. We're going to, the variable is to keep track of pairs divisible by k, by divisor, sorry. Okay, then we're gonna iterate through the number set. Then we're gonna return the tracker, cloud tracker. That's fine. Okay, so variable int let's see, divisible. We'll call it divisible. Call it divisible pairs. There we go. equals 0 at this point because we haven't started. We'll make a for loop. We'll make it to the length of the number set. Actually, we don't have to go all the way through the number set. We can get to the very last digit. So we'll do number set dot length -2. You'll see why in a second. If that didn't make sense, it will in a moment. So now we're going to get the current value. No, actually, we're not going to do that yet. So, yeah, we're going to need a second for loop. We're going to start at 1, actually, because j always has to be greater than I, because we can't be testing the same number. And if we start at 0, we have to start at 1. Actually, we'll set this to I plus 1. Yeah. So this one will be number set dot length. I guess getting and passing here is fine, but it's easier just to do it like this. Int length of number sets is what we'll call it. Number set dot length. Okay. Guess we'll call it size. I kind of like using size better. It reminds me of the list class that I struggle with all the time. But whoops. Alright, copy that. Keep the variable names consistent. Okay, so I equals 0. Alright, so now we're going to be testing we're going to be testing each pair. So we'll go int, current pair sum. I'm going to put it to 0 for now. So we're going to do current pair plus equals. We're going to do number set of 0. I'm sorry, plus. How about this? We'll set the first one out here. We'll do current first number, and then we'll do number set of 0. I'm sorry, of I. And this one we'll do current pair second number is number set of j. So then we'll do set it out here. Int current pair is 0. Then we'll add. We'll do it like this: current pair plus equals current first number plus the current second number. Okay. So then we'll do if, we'll put a space here, if the current pair then we're going to use our modulus. if the current pair modulus, what do we call it, divisor equals 0, divisible pairs will increment it. But if that's not the case, then we'll just keep going. You know, that's it. Where'd it go? Oh. Okay, so this will go through everything, iterate through number set, put it here, and then we'll return the tracker, which is divisible pairs. Alright, so a quick run through. Divisible pairs, we have none at the beginning. The size of the number set, the number set dot length, good. The size of the number set, make sure that's consistent, yes. Okay, so this is a little bit iffy, I get worried, but it looks pretty okay to me. Yeah, we'll go into I, we'll set the first number to this number in the number set, and then the current pair sum, I'm sorry. So we need to have a current pair sum. Yeah, and then we'll add those two together. Plus equals that, plus that. And then if the current pair has no remainder when divided by the divisor, then it's a divisible pair. Alright, looks good to me. So we're gonna run it, see what happens. You know, always have some sort of syntax error. There it is, current first number, current second number. Cannot find it, okay. So maybe there's some sort of spelling error here, which is unfortunate. Current first pair sum, okay. Current first number. First number, there it is. Easy fix. Alright, current pair sum. Okay. Run it. Alright, another one. Divisible pairs. Okay, for some reason that's not working. I think I may have misspelled divisible. Divisible. Oh, this one's misspelled. Oops. Okay. Run it. Alright, check it out. So we got it to work. That's good. But we're not getting the right result. So, let's see. We're getting 3 and we need to get 5. So I think this should actually be -1. Because we just have to be 1 before the end of the set. Alright, still wrong. We increased by 1 though. That's good. We're getting closer. So for some reason we're missing one pair. Let's find out which one. I plus 1. Size of the number set. That's good. J plus plus. Okay. We're reinitializing I or J every time we go back in. Second number is being reinitialized. First number being reinitialized. The current pair sum being set back to 0. Adding this to this. Getting the divisor. Incrementing the pairs. Looks good to me. See, if we go up to the last value of I, getting I plus 1, we're going to access a value that doesn't exist, or will we? I don't think we will, to be honest. I don't think it'll even let me go in there. That is correct. Okay. So 6 and 3. 6 is this, and then 3 is K. Okay. 1, 2, 3, 4, 5, 6. Okay. So I guess we'll have to run a test. I think we'll do a print statement here. In the case that for some reason our calculations are wrong, it's an easy first test to, I mean, that's best case scenario of us doing something wrong, you know. Okay, let's do a custom input. Boom. Run it. Okay, so 4, 7. Okay, yeah, that's not good. Okay, so the current pair sum just keeps increasing. That's not what we wanted to do, so we're actually going to initialize it in here. Copy this. Sorry. Alright. We'll just set that equal to that. Simple. Run code. Alright, it should be looking a lot better. 4, 3, 7, 2, 3. Yeah, looks good. Okay. What's our output? 5. Alright, so we're good. That's it. That's the only thing that was wrong with our problem. It's honestly pretty successful. I'm not gonna lie. Oops. I ran the same thing again, sorry. So run it. It's gonna work. Congratulations, ladies and gentlemen. I would like to thank all my fans for their unconditional support through this tough time. Got them all right. Okay, so now I want to take a little time to implement what I've been learning in clean code. So throughout the programming of this method, I tried to use meaningful variable names, meaningful method names. The class I'll keep the same. I've tried to modify it before and I run into problems, so I'm going to leave it as is. And for the most part, the stuff in the main method, I'll keep it the same as well, since that's kind of, I don't really mess with that stuff. It's for the sake of the code being tested and working on the website. So what method should only do one thing? This should only count divisible sum pairs. Okay, so what I can see is I need to allocate the calculation of the sum to another method, because that's an extra step that doesn't need to be handled by this. So we're gonna write another one. Do public int, because we wanted to return the sum of the pairs, and then sum of pairs, sum of pair, and then we'll do int first number, and then int second number. Okay, simple. Then here we'll do return the first number and the second number. I guess we can do just the whole thing. Check if divisible. And then we'll turn a boolean instead. But that's kind of, I don't know, methods shouldn't really be true or false. So let me just write this out, and then if I come up with something else along the way, we'll implement that instead. So we'll do int, and then we'll do sum of pair, and we'll do first number, I can't type, plus the second number. I'm sorry. Okay, so we'll get the sum of the pair, and then we'll do if, I mean, honestly, we should do it like this. Watch, check this out. Return sum of pair modulus. Well, that's another step. I would have to pass 3 different variables into here, which I don't like doing. 3 different parameters. Which is not really a thing I want to do. But I guess we will. Divisor again. Okay. I don't like this. Hopefully I come up with something a little bit better. So I'll pass the divisor over to this method as well. We'll go divisor. and that's what it's going to return. It's going to return true or false, and that's what we'll get, and that's what we wanted it to do in the first place. Oops. I sworn I clicked over here. Okay, it's not working. I'm scared. Okay, so we've allocated this operation to a different location. I mean, I think that's the best we can do. Is this static int? Yeah, it is. I don't understand why, but for some reason, if I don't make this method static, it won't let me call it from this method. That's something I'm gonna have to look into and learn about. So we'll do it like this. We'll do if. That's only one thing though. Okay, let's see. Copy this. Paste it here. Okay, this is ugly. This does not look good. Oh no. This looks not good. I do not like this at all. No. This is ugly. Cause look, the only thing it's actually doing is like this. So this handles that. And then it increments, okay. Check if divisible, okay. I don't know how to further simplify it, so let's read through it. This is the number of divisible pairs. We'll do count. Yeah. Divisible pairs count. Make it more clear. Alright, count divisible sum pairs. That's a verb. So we're counting the sum pairs. We have the divisor and we have the number set. Divisible pair count. We start at 0. We get the size of the number set. We set it here. We get the first number. And then we get the second number. And then we check if it's divisible. And then we increment the divisible pair count. And yeah, divisible pair count. Yeah, that's good. So here we actually find the sum of the pairs, which is what we wanted. So here we're getting the count of the divisible sum parts. That's exactly what we wanted. Alright guys, so here I was implementing some techniques I've been learning in the book, some of my external studies. It's gonna be a journey. Something I've been learning about. I didn't really see the purpose of having clean code. In my mind it was like, if it works, it works. And I get very caught up in that mentality, but the thing is, for the most part, any meaningful projects you work on, you're going to be working on with a team. And when you're on a team, nobody thinks the way you do. I mean, that's the purpose of a team. Like, you have someone focus on one thing, you delegate tasks to each person. So each person's working on something else, and when you put it all together, it needs to work with each other. And the thing about teams as well is people have their own lives, they have their own ambitions, their own goals. So someone like me, I'm working somewhere right now, but I don't plan to work there for the rest of my life. This is why I'm working on going to school, working on this programming. But you know, people's life situations change. So I might be working on a project at work and I'm gonna leave in a few years, and someone else might have to pick up that project. And if you're doing everything by yourself, fine. But if you're working with someone else or someone's gonna pick up your work, if you're making a mess of your code, how in the world are they gonna make sense of it? I think they'll be better off restarting from scratch than to make out whatever messy code you worked with or whatever messy code you have. And you need to be keeping it clean as you go, because if you have the mentality, oh, I'll make it work now and then clean it up later, you know, later's gonna come along, and then later's gonna come and go, and you're just gonna keep putting it off, and before you know it, you're gonna make it really hard on someone else. Alright, so that's about it. I'll catch you guys next time.